Hi, geometry students. These notes are an introduction to area. A lot of this might be familiar. You've probably done some area work in middle school, so some of this is going to be a review, some of it's going to be a little bit new, and we're just going to kind of get some time to practice. So the first idea here is that we have linear units and square units. So linear units measure length. So we might say that if we have this line segment, we could measure how long that segment is, and maybe it's, say, 1 unit. And then now, what if we instead have that unit extended into 2 dimensions, and now we have a square where we have, say, 1 unit here, and 1 unit long here, and 1 unit along the side. Then we would say that the area inside is 1 square unit. And so we get the sense that square units measure area. Which leads us to our definition of area, which is the area of a closed region is the number of square units of space within the boundary of a region. And at the beginning, we spend some time when we're first thinking about area just counting squares. So if you come down here to the rectangle, you'll see, oh, we could just count up how many square units are in this rectangle. But if we have something really big, that's not the best use of our time. So then this leads us to some shortcuts. So you probably know that the area of a rectangle is equal to the base of the rectangle times the height. So in this example, to get that 10 square centimeters, we would say that the area is base times height with a base of 5 and a height of 2. So we get a total area of 10. And here it says square centimeters. You could also write centimeters squared like that. So now that we have a square in the second picture, and you probably also know what the area of a square formula is. It is, because you have base and height are the same, we just say the area of a square is s squared, where this s is a side. And I forgot to say what B and H stand for, even though you probably know, but B is the base and H is the height. So coming back over to the square, the idea would be the area here is the side length squared, which is 4 times 4, or 4 squared, which is 16 centimeters squared. So those are just some really basic examples along with the 2 formulas, and now we're going to see something a little bit more interesting. So my first example here says find the area of rectangle X, Y, Z, B, and instead of being given the base and the height, we're given the height and this diagonal. And since we know that a rectangle has right angles, we know that this is a right triangle formed. So we can think about using either Pythagorean theorem, or in this case, it might even be Pythagorean triples. I'm just going to write a quick note. So we can use Pythagorean theorem or triples. And in this case, I know that 5 something and 13 are a Pythagorean triple, and what's missing would be 12. So I know this is a side length of 12 centimeters, and then I can actually calculate the area. The area would be the base times the height, so it would be 12 times 5, and that will give me 60. And then for my units, because I'm doing centimeters times centimeters, I should have square units, centimeters squared. Okay, looking at this next example, it says the area of a rectangle is 100 square inches. Find the value of y. So if I know the whole area inside here is 100 square inches, then I also know, if I kind of set up my formula, I know area equals base times height, and then plug in what I know. Well, I know the area, what I'm going to replace a with is the 100. I don't know what the base is. The base is y, and then my height is 4. So this creates an equation where I can solve for y. So I could divide both sides by 4. and I would get the base length of 25. And if you think about units, this y is a length, it's not an area, so it'd just be 25 inches. There wouldn't be any squared inches. Okay, so now there's a you try problem for you to try right here. So what I would like you to do is pause the video, try this problem, and then press play when you're done. We'll be talking about the solutions in class. Okay, so moving on to area of triangles. Again, this is something that you might remember from previous years of math class. So we have a formula to calculate the area of a triangle, and that is 1/2 the base of the triangle times the height. And the key understanding about base and height here is that since there are 3 sides of the triangle, any one of those sides could be the base we're pulling from. The way you decide is it has to be the side where the height dropped is perpendicular to that base. So if you look at the first example, we have the height of 5, and then if I'm deciding should I use for my base 6, 12, or 14, well, it has to be the side that's perpendicular to the height 5, so my base should be the 14. So I'm going to do, the area is 1/2 of 5 times 14. 5 times 14 is 70. Oops. And then 1/2 of 70 is 35. Now this problem didn't give us units, so we could just say 35 square units. All right, so let's look at another example now. In this next example, we have an obtuse triangle. So in an obtuse triangle, the height, and by the way, the height is the same as an altitude. So we've talked about altitudes before in this class. So we can kind of think about the height as being an altitude to one of the sides of the triangle. So notice that the height is outside of the triangle, and that's okay. So we have a height of 6 feet, and my base that I want to use is the side of the triangle that is perpendicular to the 6 feet, which would be 10. So I still want to use just a side length. I don't care that the height is 3 feet from the triangle. I just want to use the side length of 10. So I would say that my area is equal to 1/2 of the base times the height, so 10 times 6. So I'm doing 1/2 of 60, which is 30. I'm thinking about my units. My units are feet here, so it should be feet squared. So now there's a problem for you guys to try, so pause the video, give this second you try problem a go, and we'll be checking answers in class. So now that you're done with that you try problem, we're going to flip over to the second side of the note sheet. And we're going to remind ourselves about special right triangles. So notice in special right triangles, because we have a 90-degree angle in our triangle, the base and the height are both sides of my triangle, but sometimes you're not given those values. So the key is that if we remember what the relationships are and we have an angle that is the angle of a special right triangle, we can use the relationship in order to figure out what the missing side lengths are. So in this case, I know what my hypotenuse is. I know my hypotenuse is 8√2, and I know it's a 45, 45, 90 triangle. So I know in that situation, if the hypotenuse is square root times some x, then that x is exactly what the length of the other two sides are. So in this case, I know that my x value would be 8. So that, because it's 8 times √2. So that means that this side is 8 and this side is 8. And then I know enough information to actually set up my area formula. So I can do the area equals 1/2 base times height. And in this case, the base and the height are the same, so it doesn't matter like what we're calling what. So I'm going to get 1/2 of 64, which is 32. And again, I don't have units here, so we would just say square units. So in this next example, I see it's a 30, 60, 90 right triangle. And in 30, 60, 90 right triangles, the relationship, and remember that in 30, 60, 90, you think about a short leg and a long leg. So this is my short leg, this is my long leg. And the way you can tell them apart is that the long leg is opposite the 60-degree angle. So since a 60-degree angle is bigger than a 30-degree angle, it forms a larger side across from it. So the 30 degrees is opposite the short leg. And the hypotenuse is always twice the short leg. And the long leg is always √3 times the short leg. So if we come over to our example, I see there's 30, so across from 30 must be my short leg, and across from 60 must be my long leg, and it's sometimes helpful to write that in. So then I want to get the short leg first from the hypotenuse because it's hard for me to go straight from the hypotenuse to the long legs, but I know the short leg is exactly half the long leg. Since the hypotenuse is twice the short leg, you can kind of work your way backwards. So this would be 3 for my short leg. And then my long leg is √3 times x, where x is the short leg. So I would just say the long leg here would be 3 times √3. So now I have my base and I have my height, and I can set up my area formula. So I'd say area equals 1/2 of 3√3 times 3. And I would get 1/2 of 9√3. And you could either get a decimal answer or just leave this as a fraction. So I'm actually going to leave it as 9√3 over 2. And again, I'm not given units, so I'm just going to write square units. So now there's another you-try problem for you to try. So remember, take a look at the 2 different special right triangle relationships and decide which one is going on here, and then see if you can use it to get the missing length that you need in order to find the area. So you can pause the video and press play when you are ready. So the last part of this video is going to be talking about composite areas. So the idea of composite areas is that they are areas put together of different shapes, and the idea is if we can just break these areas down into shapes that we know formulas for, then we can add up the areas of those smaller shapes and get the whole area. Sometimes we can also use subtraction in order to find a specific area, and that's what I'm actually, if you notice, we have the same diagram twice and then the same diagram twice again. So I'm actually going to show you 2 different ways to solve each of these. So in this first one, example 1, suppose we're trying to find this whole area in here. Well, one way of thinking about it is it's this larger rectangle. If I kind of close off this little hole, it's this larger rectangle subtracted by the smaller rectangle. So I could even kind of think about it as area of large minus area of small. And if I can come up with a formula for each of these, or a value for each of these, then I can get the exact area here. So now, if I want the large area, I know that it's base times height because it's a rectangle. I see the height is 14, and the base, to get the length all the way across, I'd add 6 plus 5 plus 7, because if I see like all 3 of those will add up to give me this length here. So 6 plus 5 is 11, plus 7 is 18. So I know this length is 18. So the area of the large rectangle should be 14 times 18. And I want to subtract from that the area of the small rectangle, which is the 5 times 9. And if you do 14 times 18, you might need a calculator. You get 252. And I'm subtracting from that 5 times 9, which is 45. So I get 207 square units. Now, Another way of doing this, so I'm going to kind of slide over to the second example, is instead of thinking about the area I don't want and subtracting it from the whole, I could just divide this like horseshoe shape into smaller rectangles and then find the area of each of those smaller rectangles. So suppose, and there's more than one way to do this, but suppose I kind of like chop these two legs off and kind of think about each of those rectangles separately. Then there's 1, 2, 3 rectangles. Well, since this is like a straight line across, I should know that the length here is that same value of 9. And I also know from the previous one that this here is 18. And lastly, if this here is 9 and the whole thing is 14, then this must appear to be 5. So if I see these three areas, I see I have an area up top that would be 18 times 5. And I'd add to that the area of this rectangle, which would be 9 times 6. And then I need to add to that the area of the last rectangle, which would be 9 times 7. So if I add those three things up, 18 times 5 is 90, plus 9 times 6 is 54, plus 9 times 7 is 63, and if I add those up, what do you know? I get 207 square units again. So I should get exactly the same thing as I get here. Okay, so one last example before the final U-try problem. So I'm going to kind of draw a line here so it's not confusing about where the work goes with. Okay, so looking here, we're going to start by doing the first way where we do like a larger area subtracted by a smaller area. So to do that, I want to kind of cap this off. So the larger area would be this whole rectangle here. So I do area of the rectangle, and I'd want to subtract from it this white square up top, sorry, right triangle. White triangle, not right triangle. So the area of the rectangle would be 4 meters times 6 meters minus 1/2. It should be base times height here. Well, it looks like the height is 4. Sorry, the height is 2. And then the base here would be exactly the same as the base here. So it's going to be 1/2 of 4 times 2. And if I simplify that, I'm going to get 24 minus 4 times 2 is 8, divided by 2 is 4. So I end up with 20, and I had units here. My units were meters, so I do meters squared. And so that's the way where we say, oh, we have this larger area and we're subtracting a smaller area. The other method says, let's divide the shaded region into shapes that I can find the areas of them. So in that case, I could like put a line right there, and then I have these two small triangles up top, and I have a rectangle or maybe even a square at the bottom. So the idea there would be, well, for the square, I can see that since this whole length was 6, but this chunk is 2, then this must be 4 here. So I would do, I'm just going to put a little dividing line, I would do 4 times 4 for the area of the square. And I'd add to that these two triangles, and we can kind of see that they're the same, right? But even if I didn't, then I would know that, well, that is the midpoint of this line segment. So this is 2 and this is 2, which means each of those triangles is 1/2 of 2 times 2 for the base and the height. And then there's 2 of them, so I'm going to write that twice. I almost ran out of space, but hopefully you can still see that. Those are 2's. So what's this going to become? 4 times 4 is 16. 2 times 2 is 4, divided by 2 is 2. And then I have another of that, so it's another plus 2. And what do you know? 16 plus 2 plus 2 is 20. And we get the same answer as we did this method. So that concludes the notes of this video. You still have 2 more U-try problems to try at the bottom. For the first one, you can do it either way. You could either of these two methods. This one probably makes more sense just to do where you divide it up into the two shapes and then solve that way. So we will be, again, going over these solutions in class.